half sheet I gave you first, I use this as a lead in to what we're going to talk about so you can understand what it is that we're actually doing. So it takes 8 seconds for you to take one breath in and out. Do you remember it takes 8 seconds to complete one cycle? Remember that? Okay, that's the period of the function. So 8 is the period of the function. When your lungs are full, they hold 4 liters. So the top of our wave is going to be up here. When they're empty, they hold nothing. I'm not a scientist, but I think your lungs can't actually be empty. Does that make sense? Like but we're going to pretend it goes down to 0. So if the maximum is 4 and the minimum is 0, where is our center line going to be? 2. Okay, so let's just dot that in. That's where our center line is going to be. I'll try and make this as straight of a line as possible here. So we're going to start in the center. We're going to breathe in. So we're going to go up to 4. So at 2 seconds, you're going to be up to 4 liters. And then at 4 seconds, you're going to be back to your center line. At 6 seconds, you'll be down to nothing. Again, I think just in theory, we're going to say that it's nothing. I don't think your lungs can actually be fully empty. And then at 8 seconds, you'll be back to the center. So do you see how I made it take 8 seconds to complete one breath in and out? 8 seconds was the period of the function. So we can go ahead and connect those. I'm not here to grade your art skills, just do your best. But I want you to continue that for one more cycle. So where would the next point fall? After 8 seconds, we're back to the center. Then where's the next one going to be? Yeah, at 10 seconds, we're going to be where? Yeah, at 4. And then 12 seconds, you'll be back to the middle. 14 seconds will be empty in theory. And then 16 seconds, you'll be back to the center. So again, another 8 seconds to complete, another breath. So you're breathing in and out. You gonna make it? No, no. Well, just keep breathing. All right. So I made a little table for us there. We can put in our seconds. We kind of just used all of the even numbers for our seconds and went 0, 2, 4, 6, 8. I put it on a half sheet to save paper. You can keep flipping it back and forth if you want to, but we used all the even numbers for our seconds. And then for our breath, we started at 2, that was in the middle. And then it went up to 4, back to 2 in the center, breathing out down to nothing, again, in theory, and then back to the center.
Is there always like on the graph, if it goes all the way, the max is 4, do you have to start at the middle?
Yeah, I was trying to not mess with the function too much because I want us to write an equation. Okay, so out front is the amplitude. What is the amplitude of our graph? How far from the center line? 2. Okay, so 2 goes out front. I'm going to hold off on the B value for a second. Remember it went A, B, C, D? Okay, I didn't shift it left or right. That's kind of what you were asking about. That makes it super complicated, so I didn't do that. And then it's going to be plus where our center line was, which was also 2. Now, to get the period of the function, you take 2 pi over whatever that B value is, and that gives you the period of the function. So how many seconds was it for one full breath in and out? 8. And I'm going to put 8 over 1 so that we can do a cross multiply here and solve for that B value. So if you cross this way, it's 8b. If you cross this way, it's 2 pi. And then to solve for b, you would divide by 8. So 2 pi over 8, which would reduce to pi over 4. So we built an equation. And then I threw a couple follow-up questions in here. And this is kind of what I'm leading up to. Again, I'm doing this as a lead up to what we're going to do today. So at what times do your lungs hold 0 liters of air? So where are our zeros on here? 6 and then 14. So 6, 14. when would the next one be? Could you continue it? Why 22? Yeah, you're going to do plus 8n. It's every 8 seconds. I'm going to skip 5. Let's go down to 6. When do your lungs hold 4 liters of air? So flip it back over. When are we up here at 4? How many seconds? 2 and then 10. So 2 and then 10. And then the next one, oh, I wrote it in the wrong one. Sorry, I wanted to skip one. You'll see why in a second. 2 and then 10. And then the next one would be 18 and on and on and on. And again, you would keep adding 8 seconds each time. Forever and ever and ever. All right, 2 liters of air is going to be a little bit different because that's the center one. Do you see how there's more of them? So that's 0 and then good 4 and then 8 and then 12. We don't have to list them all. But if you kept on going, it's not plus 8n. It's every how many seconds? Yeah, and why does that happen? Like, why is it 4 instead of 8? Yeah, it's the middle. So like you keep hitting that value more often. Now here's what we're leading up to. This is what the lesson is sort of on today. Do you remember me saying so far, all I can ask you about are the numbers on the table? I haven't taught you how to get the ones in between yet. Today's that day. When do your lungs hold 1 liter of air? Well, flip over. Here's 1 liter. There are times when you hold 1 liter of air, but do you see how it would be a decimal of seconds? It's not right exactly on a nice whole number. Or see, that's like the goal of what I would want you to do here. Now, what you would have to do is take this equation and set it equal to 1 and then solve it and work it out. So what the lesson today is on is how to solve equations like that so that you can get the values that are in between. Okay, I put 12 questions on here. We'll kind of see how this goes. Again, the point of notes is to understand what's going on. So if we do enough that it feels like you guys have got it, I might not make you do every single one on here. All right. Now, you know how to solve equations. So without me saying anything, what would you do first to start solving that? You would subtract 1. Good. Now I'm going to try and get you to do both of these steps at once because this is pre-calc and I think you can handle it. You would subtract the 1, so you'd have -1, and then you would divide by 2. Good. So it's going to be sine of x equals -1/2. Oh my gosh, that's on the unit circle. It will turn out that way. You are going to get 1/2, square root of 2 over 2, or square root of 3 over 2. Now you have to figure out what quadrants you're in. You can either remember that all students take calculus thing, or what I tend to do is sine is the y value. In what quadrants is your y value negative? Like you'd have to go down. Good, 3 and 4. So what you are going to do is draw a triangle in quadrant 3 and a triangle in quadrant 4. You only need to label one of them. You know how I harp on and on about label the triangles, label the triangles? They're the same triangle, just reflected. So you can just do one or the other. I don't care which one. It doesn't matter. Yeah, sine is the y value. And those are the quadrants where your y value is negative. You have to go down to get a negative y value. So that's where the -1/2 goes. What is the angle? Because that's our goal here is to get the angle. What is the angle that goes across from that? Pi over 6. Now you're going to get 2 answers, one for each triangle. The denominator is going to be 6. You can't change that. So what is your angle in the 3rd quadrant that is something 6? And you kind of want to let your instinct kick in here. You've filled out a lot. It is 7 pi over 6. Good job. And then what is the one in the 4th quadrant? So we only go forwards for these, which is, I was waiting to see if somebody would come up with that 11 pi over 6. We only go forwards for these ones, but I'm glad you're thinking of that. But that is for the inverse trig. These we only go forwards. Okay, let's try it again. What would you do to start solving this one? -5, that would give you 4 minus 5 would be -1. And then you would, okay, it's practically the exact same question we just did, except cosine. So same thing, but we're going to be in different quadrants and we're going to have different angles. Cosine is the x value. In what quadrants is your x value negative? Like you'd have to go. Good, perfect. Look at this. All right, 2 and 3. And at the end of the day, and I say this all the time, there's only 4 quadrants. If you get stuck, like give it a guess. You only have 4. Now, cosine is the x value. So your negative a half goes along this side. That means your other side is square root of 3 over 2. So what is our angle this time? Yeah, pi over 3. Perfect. And so again, you get 2 answers, one for each triangle. And the denominator is going to be 3. Just think of you filled out a lot of unit circles at this point. What's the one in the second quadrant that has a denominator 3? Yep, perfect. You guys are so good at this. 2 pi over 3. And then in the third quadrant is 4 pi over 3. Perfect. You guys got it. The third one? Well, we've done the least amount with it, to be fair. So, all right. For this one, what would you do to start solving it? You want to get sine by itself. Add 1, so it's going to be positive, and then divide by 2. Now, yes, see how it's squared? We're going to square root. When you square root, you get a plus and a minus, which I like when there's a plus minus, because you don't have to worry about which quadrants you're in. You're in all of them. And it looks like a bow tie, which I just think is cute. Now, when you square root, you're going to square root the top, square root the bottom. What is the square root of 1? 1. And the square root of 2 is square root of 2.
Yeah.
Good. So it is plus and minus. Oh my gosh. Hey, guys, it came out to something circled. Isn't that crazy? No, the square root of 1/4 is 1/2. It's the other way around. No, but like that's where you're like, I mean, yeah, I'm glad you're thinking of that because sometimes it comes out to a 1/4. And then when you square root it, you get a half plus minus. So draw your triangles in all 4 quadrants. We're going to get 4 answers this time. And again, it looks like a little bow tie, which is just cute. It's your square root of 2 over 2 triangle. And so that means your angle, your reference angle is pi over 4. So when you list out your answers, there's going to be 4 of them, and they're all going to be something pi over 4. So we get pi over 4. That's the one in the first quadrant. What's the one in the second quadrant? Yeah, 3 pi over 4. Yeah, it's all the odd ones, right? 7 pi over 4. Good job.
So you take the number that you get when you have the sign of x equals and what that would sign after them.
Yeah, so sine is the y value. Well, in this case, they're both the same, but like sine is the y value, so I put that there. In this one, sine is the y value. For this one, cosine was the x value. So then I had to get the other side. Correct. Yep. All the denominators are going to be the same. I'm going to skip this one. I didn't put one like this on the test, so we're going to just leave that for right now for the sake of time. I can show you it if you are interested. All right. Now this one looks super complicated, but I promise it's not going to turn out that bad. Remember, it has to be on the unit circle. You have 2 terms here. This is the first one and this is the second one. What do they both have? We're going to do GCF. They both have what? Cosine. Actually, they both have cosine squared. Good. So what you're going to do is put a cosine squared and we're going to factor that out. It's no different than factoring out anything else. You're basically just going to remove it, right? So what is left when you take that out? Square root of 3, cotangent. Now hold on. Minus. Now, when you take something and divide by itself, it's 1. Good job. Perfect. And so it just became a buy one, get one problem. It's not any harder. You just have 2 questions now. You're going to set cosine squared equal to 0, and you're going to set this whole thing equal to 0, and you now have 2 problems, is what happened there. Now, the good news over here is when you square root 0, you just get 0, and you can't plus and minus a 0, so that's simple. That is not going to be a triangle. That is going to be a circle.
Isn't that like the proof, like the 1, 0?
Yeah, we're going to have 1, 0, 0, 1, 0, -1. I don't know. We're going to find it. Cosine is the x value. So using words like up, down, left, right, where is the x part? 0.
Up or down.
Yeah, up or down. So that's right here and right here. And so you get 2 answers. The one at the top is pi over what? 2. Good. And the one at the bottom is 3 pi over 2. I get that this looks awful, but just persevere. What would you do to start solving it? You would add 1. Yeah, well, divide by square root of 3. Now, it is either that or that. You have a 50-50 shot, okay? Do you think it is this first one, or do you think it is the second one? Good. So this is 1/2 over square root of 3 over 2. You guys were really good at that last unit, so I think you're going to be okay. And cotangent is x over y if you want to label. Now we need quadrants where cotangent is positive. Tangent and cotangent go across from each other. They're like catty-cornered, or I don't know if that's like a phrase you guys use. That's like an old-fashioned word, like across from each other. I know I need quadrant 1 because everything is positive there. And so the other one is going to be quadrant 3. The reason those two are in quadrant 1 and quadrant 3 is in quadrant 3, you get 2 negatives and they cancel and it becomes positive. All right, cotangent is x over y. So that's the x, that's the y. And here's the whole goal of the whole thing. What is the angle across from square root of 3? Pi over 3. And so we get 2 answers from that one. We get pi over 3. And good, the other one in the third quadrant is 4 pi over 3. So how many total answers to like the entire question? 4 answers. I'll skip that one too, because I'm just looking. There's one similar to that on the back. So again, just for the sake of time, I'm trying to not torture you here. Now these ones said, I should have brought this up at the beginning. It says solve from 0 to 2 pi. That's just once around the circle. Okay. This says solve for all solutions. That means forever and ever 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 and ever. Okay. So like to compare it to the breathing one, do you remember how I said plus 8n? You're going to have plus whatever. Now here's the choices. You can have plus 2 pi n. That's the whole way around. You can have plus pi n. That's just halfway around. Or you can have plus pi over 4n, which is just a quarter of the way around. Yeah, or, oh, I'm sorry, you distracted me for a second. I'm sorry, pi over 2n is halfway around. Yes, go ahead. No, those will not be on there. Those are the only 3 options. Sorry, I got distracted because he was doing something. It's totally fine. Anyway, let me just say that again. You can either go the whole way around, halfway around, or a quarter of the way around. It won't get broken any smaller than that. Okay, so what would you do to start solving for here? Divide by 2, and oh my gosh, it's on the unit circle. So I need quadrants where sign is negative. Sign is your y value. So where would your y value be negative? Yeah, 3 and 4. It's like upside down kitty cat ears. So your y value goes right there. And this is the whole point of the thing. What is the angle? That's like the goal. Pi over 3. Good job. So we get 2 answers. The one in the third quadrant that has a denominator of 3, 4 pi over 3. And then the other one is 5 pi over 3. Now here's how we write it to show that we get everything forever and ever and ever. Watch me point to this. If you are right here, do you see how you have to go the whole way around to land there again? Okay, so it's going to be plus 2 pi n because you have to go the whole way around to get to that same spot. Yeah, If you're right here, I should get out my paper clip again. If you're right here, you have to go the whole way around to get there again. So the whole way around is 2 pi. Now it's going to be the same thing for this one. If you're right here, you have to go the whole way around the circle to land there again. So plus 2 pi n. No, because you'll see sometimes it gets broken halfway around. I'll show you. I will show you, I promise.
Oh my goodness.
All right, to start solving this one, you would subtract 1. So -1. And then what would you do next? You would square root. Now you should go, hey, wait, hold on a second. You can't square root a negative, so this is good old no solution. No, we are not doing imaginary angles. No I. All right, same question, except it's going to work this time. For this one, you're going to add the 1, so it turns out positive, and then square root. Now, this does get people, but whenever you do a square root, you have to put plus and minus. So your square root of 1 is plus and minus 1. Square root of 1 is 1, it's just plus and minus. Now, that is going to be a circle. Cosine is x, so using words like up, down, left, right, we want where the x value is either positive 1 or negative 1. Good, perfect. So here's where it's positive 1. Oops. Here's where it's negative 1. And this is going to answer your question that you had up above there. What is the first one? How much pi if you're right here? 0 pi, like no pi. Now watch me point to this. Do you see how you only have to go halfway around to get to the next answer? And then you only have to go halfway around to get back here again. And then you only have to go halfway around to get there again. So halfway around is pi n. If I come over there right now, are you going to have all of this written down? That's a phone call home.
Oh, yeah.
Yeah, and I know that's weird. Halfway around is 1 pi n.
Yeah.
I know.
Is it like 0 pi and,
Do you see how in this one I had to write them separately? Because they weren't evenly spaced from each other. So I had to do this one and go the whole way around, and then do this one and go the whole way around. This one statement takes care of every single answer, because if I go halfway, I hit this one. If I go halfway, I hit this one. So I only had to write one statement instead of 2 separate things, because they were evenly spaced that time. Yes, you only have to write it once. All right, let's start solving this. I want to do, actually, maybe we'll see if I can do, actually, we'll have enough time. We'll just do all of them. You would subtract the 1. You're going to be okay. These all turn out a little bit different, so I kind of want to do them all. You would subtract the 1, so it's -1, and then divide by square root of 3. That's the same situation we were in with that other problem. It's going to be -1/2 over square root of 3 over 2. So I need quadrants where tangent is negative. Again, the way I remember this is tangent and cotangent go across from each other. If it's negative, it cannot be in quadrant 1. So it's going to have to be these two. You're going to make it. Now, tangent is y over x. So that -1/2 is your y value, square root of 3 over 2 is your x value. And so here's the question to the whole thing. What is the angle that you get there? Pi over 6, perfect. So we can just write one statement for this one, because do you see how they're exactly halfway across the circle from each other? Like you can just go halfway around and get this answer, and then go halfway around. Oh, that's a horrible circle. Halfway around and get this answer, and then just go half. So you can just write it one time. So what is your 6 for second quadrant? Yeah, 5, 6. And you just go halfway around, so plus pi n. So you can just write one statement that takes care of the whole thing. Yeah, good.
Okay, on the first one, wait, I don't know where it is. And I think it's this one, the one where we did the +2 pi.
Mhm. It's because they're not evenly spaced from each other, that you have to do it separately. You're forced to do it separately because they're not nice and evenly spaced.
Oh, so you have to write one.
Yeah, do you see how these are exactly halfway around from each other? These are not exactly halfway around from each other. Like if one was up here and one was down here, you could get away with doing that, but this one doesn't work, so you have to write it as two separate things.
That you can see in like quadrant one, like 1 and 2.
1 and 3.
One.
You could get away with this. Oh, if it was in 1 and 2, you'd have to write two separate statements. They're not evenly spaced from each other. Okay, 2 more. You guys are gonna make it. All right, first we're gonna add 3. And then what? How do you get rid of the squared? Okay, so it is plus and minus square root of 3. Which one of these is that?
The one
First one. Good. So it is going to be plus and minus square root of 3 over 2 over a half, and tangent is y over x. Which quadrants are we in?
No, just all of them.
Why is it all of them? Because it's plus and minus. I kind of like when it's all of them. You have to write more answers, but you don't have to worry about which quadrants you're in because it's literally all of them. All right, so your y value is square root of 3 over 2. Your x value is a half. I kind of can't really, oh, here, I'll try and fit that in there. But the whole point is, what's the angle? Pi over 3. Now listen carefully to me. If it was pi over 4, we could get away with just writing one statement, because do you understand how they would all be evenly spaced if it was fourths?
Yeah.
We're going to have to write two separate ones for this, though, because they are not perfectly evenly spaced. So what is the first one? Well, the first one's just pi over 3, right? So this one's pi over 3. And if you go halfway around, you're going to get to this one. So plus pi n. That takes care of all the ones in quadrants 1 and 3 that are halfway around from each other. I think we're going to get it. And then how would you do these two? 2 pi over 3 plus pi. You guys got it. Perfect. Good. So you just have to do enough of them. We're going to do one more.
Because like when you write the pi in, it takes care of
all of them.
That makes sense.
Good. I'm glad we got it. All right, for this one, what you're going to do is replace this cosecant with what? Good. I know you're like, how did that make it better, Miss Cole? It looks worse. I'm on your side. At least now it's all sines. Okay. And then what you're going to do is multiply each term by sine, with the point being it will cancel out that fraction. So first we got it so that it's all sine, and now we're going to cancel out the fraction. The 2 is part of this whole term. So we did get that one. This is all one term.
Oh.
Do you see what I'm saying? Like, that's a good question. All right, so sine times sine squared minus 1 sine. You don't have to put the 1. Actually, I don't like that there. That looks weird. I'm going to get rid of it. And then here they cancel, which is like the whole point. So it's just minus 2. Now, I hope that as you look at that, it looks kind of like this to you. Do you see that? It's just sine. That's all. So this is factoring. It would be x and x. Just watch. How would you split this one? Well, let's forget about the signs for a second. Let's 2 and 1. Cool. So it's the exact same thing except with sine. So you're going to get sine of x minus 2 and sine of x plus 1. So it is just factoring, and you can always turn it back just into a regular algebra 2 kind of problem. So now you have 2 separate problems. It just became an A and a B. What would you do to start solving this one? You would add 2, so it would look like this. And then my hope is that you're like, hold on a second. That's not on the unit circle. The reason it's called a unit circle is because it is 1 unit. Can you get to 2? No, so this doesn't yield any results. What would you do to start solving this one? You have -1. That's a circle. Looking for a word like up, down, left, or right. We want sign to be -1. So your y value down. Good. And so your answer is 3 pi over 2. Now you have to go the whole way around to get there again. Perfect. Nice job.